Good morning, students of class 9. In this period of geography, we are going to start a new chapter today. That is chapter number 3. Chapter is rotation and revolution. Rotation and revolution of the earth. So, before starting this, as introduction, I want to say something. In the ancient days, the people had very big anxiety to know about the movement of the sun, the moon, the earth, and as they observed that sun rises in the east and it comes at its highest point in the sky in noon time and it sets in the evening. So the ancient people considered that the earth is fixed body. The earth is fixed body while other heavenly bodies are moving around the earth. You can say this is absolutely wrong because this earth is not fixed body. This earth is also moving. Earth has also movement. So this person was the first person, Nicholas Copernicus. Nicholas Copernicus told at first to the world that earth has also its own movement. It is moving on its own axis as well as around the sun. What I am telling you, or Copernicus told, at first Copernicus told, earth is not an stationary object, a stationary body. Earth has also the movement. Earth rotates on its own axis, that is the rotation, and as well as it revolves around the sun, that is the revolution. So, what may be the definition of rotation? The movement of earth on its own axis. The movement of the earth on its own axis is called a rotation. Now you will say, what is this axis? Axis is an imaginary line that passes through the center of the earth. Clear? I repeat the definition of rotation. The rotation of the earth spins, S-P-I-N-S, spins. The earth spins or the earth rotates on its own axis. That own axis is the imaginary line that passes through the center of the earth. And what is this revolution? Earth revolves around the sun in an elliptical path, that is called the orbit, elliptical path. For your information, this kind of path of movement is called elliptical path. So this earth revolves around the sun in an elliptical path, that is called the revolution of the earth. Now the next topic is about the calculation of complete rotation. While this sun crosses the longitude twice in fixed time. The sun crosses any longitude twice, that you know, that you have studied in geography grid. The sun crosses any longitude, any meridian twice, and the time taken by the sun to cross that meridian or longitude twice is the duration of complete rotation. I repeat this, what is the how does it how is it done, calculation of complete rotation? About that again I want to say, the sun crosses the longitude twice, and duration to cross the sun twice regarding any longitude is the time taken to complete a rotation. Now we come to the characteristics. We come to the characteristics of rotation. So the first characteristics of rotation, right here, characteristics of rotation. First is day and night. In this is the earth. Suppose sun is here, this is the earth, sun is here, and this sun rays are falling. The sun rays are falling on half of the earth, and that portion of the earth experiences day. What are saying? The sun rays are falling on half of the earth. That lighted portion of the earth is called a day, while this half of the portion remains in dark, where the sun rays cannot reach. That portion experiences night. I repeat about this. This happens due to the rotation of the earth. The sun rays fall on half of the earth's surface, and that half of the earth's surface experiences day, while at the same time half of the earth's surface remains in dark. That dark portion of the earth experiences night. Now the second characteristics. The second characteristic is the length of the day. Day and night, we can say. The length of the day and the night. Regarding this, we can say, in summer season, especially in summer season, as we go ahead from the equator, then the length of day increases. As we go ahead from the equator in summer season, then the length of day increases, and for night we can say vice versa. It means the length of night decreases. I repeat this. In summer season, as we go ahead from equator, then the length of day increases, but the length of night decreases. And it happens opposite in winter season. In winter season, the length of day decreases and the length of night increases. Now we come to the third characteristic, that is angle of inclination. Angle of inclination. We know this earth is inclined on its own axis. Earth is inclined on its own axis. What is this inclination? That I want to say. This longitude should be a straight line. This longitude should be a straight line, but we do not find this line is inclined by 66 and half degree. It means with the horizontal latitude, this line, that may be prime meridian, this line makes 66 and half degree. So this is tilted by 23 and half degree. I want to say again, angle of inclination or angle of tiltation. I write here, or angle of tiltation, angle of inclination or angle of tiltation. Regarding this, we can say this vertical longitude should be straight, making right angle with the horizontal latitude. This line should be straight, making right angle with the horizontal latitude, but it does not happen. This is not true. This line is inclined or tilted. This line is tilted to the horizontal latitude by 66 and half degree. Means this vertical meridian makes 66 and half degree with the horizontal latitude. Suppose this is the imaginary, that should make 90 degree. So by how much it is tilted? It is tilted by 23 and half degree. So this angle became the angle of tiltation, and this angle is called angle of inclination. So I write here angle of inclination of the earth is equal to 66 and half degree, while angle of tiltation is equal to how much? 33, no, not 23, 33, 23, yeah, correct, 23 and half degree. If you add these two, you will get 90 degree. But in fact, this is not 90 degree. It is tilted by 23 and half degree, and it is inclined with horizontal axis with 66 and half degree.